Hello, can you hear me? So we have Muhammad Kaldi, Aaron, Ben, Monica. Monica, you need to. Where are you right now? Are you still in Rhode Island? Okay. You never picked up the DE10 board from me. I give it out on like the first thing on our first class, but you never pick it up. So we need to figure out ways how you can get the board because you need to use the board for the assignments. Well, not this assignment, but later assignments. Okay. So please email me about the logistics. We need to figure out for you. Okay, I think everybody else is fine because they were here on first day of class. They picked up everything. Okay, all right. So we can talk that offline. All right. So now we have. Let me see. We have Muhammad Kadi, Aaron, Band, Monica. Anybody else? Okay, Manny, Christian, Rawa. Okay. Okay, Muhammad Agami. I'm sorry, Abdullah Agami. Okay. I think we're missing one student. JC, are you here? JC, are you here? Okay, for those who are already in the live, please get your Arduino ready. Okay, We are going to continue what we left from Tuesday. Okay. How's the lag for the voice? Is it good? Okay, so everybody's in. Let's start. So look at the screen for the Arduino. This is what we had from Tuesday. So this particular code will execute, and it is going to output some basic parameters for the file we're trying to read from the SD card. Okay, all right. Well, let me see. So make sure that you have that ready, and tools TC 3.5 board. Okay, make sure that your code compiles. Can anybody or everybody see my screen? Okay. How about now? Can you see my screen? Okay. There. Okay. So last class we talked about a bunch of bytes that you read from your SD card. Okay, and there are a lot of bytes. So the way we did it is we read from SD card and we put it into a buffer, and we put it into a big buffer. Okay, and then we read from the buffer and we put the values on the screen. So we develop a loop to put 50 values on the screen. Okay, so today we're going to continue this example and develop a new program. Okay, once we do that, we're going to talk about the assignments D1. Okay? A BMP file has a very special structure. The first bytes or first few bytes, they are the headers for the BMPs. So those values are has special meanings or definitions. So now, if you look at the screen, we talk about these values from previous class. Okay, the size of the header for BMP is fixed. So all BMP files have exactly the same size for the header files. Okay, the exact size is 54 bytes. Okay, so if you do this loop here, you can read the entire headers using the big buffer, and this loop here is going to output all the bytes from headers to the terminal. Okay, all right. So you should make the change from 50 to 54, and then make sure that you run the code again. Okay, then we can see the behavior of this new program. All right. So nothing changed here. Everything else is fine. All right. So what is the big deal about these headers? The headers contain the information for the file. Especially important is the width and the height of the image. When you read the headers, you can determine the size of the image just by looking at specific bytes in the headers. Okay. Last class we talked about how to decipher the bytes because they're not really saved in the normal way we're used to. Okay. So today we're going to look at how do you read the pixel values. When you do this, you're going to fill 1,000 bytes into this buffer. Okay, that 1,000 bytes is going to be the same size as the big buffer. Okay, but it's not the size of the file itself. The first 54 bytes are the headers, and then after the headers are the pixel values. Okay, pixel values. So now we are going to create a new loop that will print out the pixel values. So the starting location is not 0 anymore, it's 54. So what we're going to do is we're going to print out, say, 3 values. So it is going to be 54 plus 3. Only 3 values, 3 bytes. And let's put some message in between. So we know we're printing out pixel values. So please add this code to your program. Okay, are we done typing? Okay, so I assume everybody is all set, right? So now what you need to do is you need to verify this new program and then download it to your board and then run it again. Okay, please do that. Okay, so this is what we care. This is the new code we just added. Okay, so do you get this? Do you get these three values? So far, we have one confirmation from Manny. Yes. Oh, by the way, Manny, I responded to your email with the problems, and I show you why. Are you all set now? Okay, no problem. Take your time. Okay. Let's continue. So let's look at these values. So there are 3 bytes, FF00. Remember, everything is in hexadecimal. Okay. So what does this mean? This means this is 1 pixel. So it's 3 bytes per pixel. And FF is the blue, green, and then red. Again, if you cannot see the ports, that means you either didn't install the library properly or you're not administrator to your machine. So that the privilege that you have doesn't let you do stuff like this. So make sure that when you install the software, the library, when you run the software, you are the administrator to your machine. When you plug in the board, when you go to my computer, you should see it right there. Okay? If you don't see it, that means you're not administrator to your machine. Then you make sure that you set your account, your Windows account, to be administrator to your machine. That's, okay. Anyway, so let's come back to this. So this is BGR, 3 bytes per pixel. Now remember, when we work with this type of files, it is little endian because we know that what we are used to is RGB, but it is not saved as RGB. It's always saved as BGR. Understand? Okay. All right. So this is 1 pixel. Okay. Now, based on this pixel, this means this color of the pixel is blue, no green, no red. Okay. Blue, no green, no red. If you go here, instead of doing a 3, you do a 6. That means you want to do 2 pixels. Verified, and download the program and rerun it. You see more pixels values on the screen. Okay, so if you run, so now you see 2 more pixels, but they're the same value. Okay, all right. Now, if you recall, what is the resolution of this image we're testing? Okay, can you see my screen? Yes, video is buffering. It was buffering on my side too. Can you see my screen? Can you hear my voice? Okay, so everything is back online. Yes, that's good. Let's give them more time to rejoin the live. I think some people got disconnected. Okay, so we have everybody's joined. All right, let's continue. So I just print out 2 pixels. Okay. Anybody remember the resolution of this image we're testing? What is the resolution? Anybody? That's right, 16 pixels horizontal and 24 pixels vertical. Okay. So what we're going to do is we're going to print out 16 pixels. Now, if you look at these values they are identical. See that blue, 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 blue. So what I'm going to do is I'm going to copy this to the notepad, and then I'm going to format them as a group of 3 bytes per row. So if you do the counts, we have 2, 4, 6, 8, 10, 12, 14, 16 blues. Okay, 16 blues. 16 blues. So that means when you start reading the pixel data, you read a bunch of blues. So now let's look at the picture itself. This is how it looks. So let me zoom in. This is the picture. Blue, green, red. So when I start reading the file's pixel data, I'm getting the blue first. So what can you conclude based on this behavior? We're not getting the red, we're getting the blue first. What can you conclude this behavior? But we know it is Little Indian, but why are we getting the blue first instead of the red? Remember, Little Indian means how we save the pixel. Okay. uh, MSP. What does it mean, MSP? Anybody else? When you read the pixel data, which is immediately after the headers, you're getting the blue instead of getting the red. That means the way they save the image is upside down. That means they save the image this way. Okay, but when we look at image, we view the image this way. Right? It is saved upside down. Understand? So based on these experiments, we conclude that the BMP pixel data is saved upside down. Okay, okay, great. Let's move on. Okay. When you save the image upside down, you got two ways to do this. You can save it this way, or you can save it this way, right? Left to right or right to left. So how do we know which way it is? Now you can set up a different image and then read it, then you can see which way it is saved. But without doing that, I'm going to tell you. The BMP image is saved from left to right, upside down. Okay. The reason it is left to right is because when you put the image on the screen, this edge is on the left, this edge is on the right. So when you view or when you address the pixels on the screen, it is left to right because the screen is displayed from left to right, not from right to left. So the image itself is stored upside down, left to right. Understand? Okay. All right. Now looking at this picture, uh, the size of the blue is the same size of the green, which is also the same size of red. Do you agree? Okay. So now I'm going back to the code to see. I want to read the green. Where should I start? What value should I put in there such that will start reading the red. I'm sorry, the green. Okay, because this value means I'm reading the blue. I want to read the first green. What value should I use? Well, that's the value we had. This will still give you the blue. I want to skip the blue. I want to read the green. Okay. All right. Now we know each pixel is 3. Okay. And how many pixels do we have horizontally? 16. Okay. And how many vertical lines do we have for the blue? Okay. So this means that I'm looking at header bytes per pixel. Each pixel is 3 bytes. Each row has 16 bytes or 16 pixels, and there are 8 rows for the blue. Okay, so this value will be the starting of the green. This is the starting of the green. So if you do a +3, that will give you the first pixel of the green. So again, let's go over this again. This is the header, bytes per pixel, 16 pixels per row, 8 rows for the blue, and then 1 pixel after that is going to be the green. So let's file save, verified, and then you can download, and then we can look at the new numbers. Okay, so this is a new number. So going back to board, this is still true. The new value is this. Now, from what we have learned so far, we know this is BGR. So that means this is the green one. Okay, so make sure that you have these values here and rerun your code with the new program, and then make sure that this is what you get. Okay, this is what you get. So please try it and let me know if you are done. So we have Aaron done. We have Manny done. Okay, I would like to know who is still in the chat room and watching the live because the number of students dropped. Okay, uh, we have Muhammad Akaldi, Manny, Aaron, Van. Anybody else? Please type your name and respond to my request. Okay, Jesse, yes. Van, yes. What about Abdullah Agandi, Arawa, and Christian? Are you still here? Monica, are you still here? Abdullah Agandi, Monica, are you still here? Okay. So somebody must have dropped because the number is not right. So Abdullah Agandi, are you still here? Okay, I guess he's not here. All right. All right. So we're all good running the program, right? What number should we need to use to see the red? The first red. This is the image we're dealing with. I want to see the first red, which is right here. Okay. We just changed the program to see the first green, which is right here. I want to see the first red. So now we need to make a change here. How do you see? How do you see the red? What number should we use? right? So if you look at it, we have the header 54, number of bytes per pixel, number of pixels per row. 8 means 8 rows for the blue. You skip that. Now it is 8 rows for the blue and 8 rows for the green. So it's 16 plus 3. That will be the first red. Okay. So this is the new number we need to deal with. Let's save this, verify, and rerun. Okay. So now this is the new value. So you can see how they arrange the bytes. It's B, G, R. So this proves you this is how exactly they're stored. The BGR. Okay. So make sure that you run this and then you get the new different values. Okay. Different values for the red. So Aaron's output is good. Anybody else? Okay. Again, if your computer cannot see your port, it's because you're not the administrator when you install the software. When you install the software, there's a step you need to load the driver to your machine. If you're not the administrator, you cannot load the drivers. If you cannot load the drivers, you cannot see the USB. You cannot see the USB, you cannot see the port. Very simple. All right. So what we did today is extra coding to extract the pixels values. Okay. All right. So let me close this window here. Now we know the pixels are stored as BGR. not RGB. Okay, because of little endian. And each pixel is 24 bits. Thus, it is 1 byte, 2 bytes, 3 bytes. So it's 24 bits per pixel. That's usually the size of the BNP. Each pixel is 3 bytes or 24 bits. Okay. All right. Now, what is the big deal here? The big deal here is um, in embedded system, usually we don't work with 24 bits because it's too demanding. So 24-bit BNP. But for embedded systems, we use 8 bits. Okay? Why? Because in embedded system, you don't have a lot of memory to store these images. So the next task we need to know is how can you compress or change the bits you use in a BNP. Okay? Now you cannot change the file itself. Okay, you can only compress the bits using a program after reading the file. Understand? You're not changing the file. You're changing how to interpret the data. Okay? So for 24-bit BNP, we have 8 bits, 8 bits, and 8 bits. Okay? So the first 8 bits is red. The second 8 bits, blue. I'm sorry, green. And then the last one is blue. For 8-bit BNP, we have 3 bits plus 3 bits plus 2 bits. So we have red, green, blue. Understand? But how do you get from 8 bits to 3 bits, 8 bits to 3 bits, 8 bits to 2 bits? How do you do that? Anybody? Okay, but the problem is you need to contain the data in 8 bits. Okay, and the original data is 24 bits. So what Aaron said is correct. You need to divide. Okay, so how to do that? 24 bits divided by some number will give you the 8 bits. Okay, but you cannot do this as a 24-bit together. You have to do it 8 bits by 8 bits. Okay, so let's put it here. From 8 bits to 3 bits, you have to divide by 5 bits. So 5 bit is 32. Okay, from 8 bits to 3 bits, you divide by 5 bits, which is 32. From 8 bits to 2 bits, you need to divide by 6 bits, so which is 64. After that, you need to combine the 3 and 3 and 3 into 8. Then you can get the 8 bits version of your image. Okay? Any question about this operation? This operation is not uniform. You can see that if you divide everything by 32, easy. You just divide everything by 32. But you will do the first bytes or the first 8 bits by 32, the second by 32, the last one by 64, such that when you do that, you end up with red, green, blue, or 3, 3, 2. Understand? If you do, please say confirm that in the chat room, please. So far, we have many confirmed. Aaron confirmed. Christian confirmed. Anybody else? Okay, 2 more, 3 more, 6 total so far. What about Van and JC? Okay, great. Everybody's correct. Okay. So now, if you look at this, when we work with the Arduino platform, this is the only outputs we have. Okay. So right now, this is how we present the data, bytes by bytes. Now it's okay for headers because usually the headers, many of them are constant. Okay, you are only interested in a few bytes in the header. But if you want to examine the pixel data, this kind of presentation, byte by byte, is not that great. Okay, because it's not really readable. So when we present the data, usually what we do is we present the data as a two-dimensional matrix, meaning that instead of putting the bytes one at a time, you put in 3 bytes or 24 bits as one number for one pixel, and then the next location is going to be a different value for different pixel. So the ideal output for pixel data presentations is like this. Then you get more values. You get more values. So eventually you are going to hit the green, and then the red eventually. Okay. Are we clear about these presentations of the pixel data using a two-dimensional matrix? Remember, the data is not stored in the two-dimensional matrix. This data is stored in a buffer. But when you present the data, you want to present it as a two-dimensional matrix. Understand? Please confirm. Yes? No? Okay, we have 5 students confirmed. We're still missing 3 students. Christian, Monica, and what else? Christian, Monica. Agamdi. Okay. All right. Okay. So now let's look at the assignment that's due next week. Remember, D1 is supposed to due today, but I'm extending it to next week. Okay. D1 is very straightforward. So what you need to do is you'll be given a file, a BMP file, 24 bits. Your job is to extract the information from the header. Remember, the header is not the whole file. The header is the first 54 bytes. And your job is to extract the width and the height of the image. So the resolution of the file, okay? And you need to write a program to do that. Now, I'm not going to tell you the resolution of the image, okay? Your program should be smart enough to understand how to extract this information. So, but there's a limit. It cannot be infinity. The limit is I can give you any image BMP wise up to 4K resolution. Then your program should be able to tell just by looking at the headers and extract the resolutions, width and height, and display the reading on the terminal. Okay. Any question about the assignment? You need to submit the source code on ULearn. There's no more in-class demonstration, so it's going to be a video. So okay. So I'll give you a file, a different file that you need to put on the SD card, and then run your program, and then you should see the outputs, and then give it to me. Okay. Yeah. So your program should be able to do that. Remember, your job is to read the header and then figure out the logic and the math. It is not very complicated. It's very straightforward. So this is will be due next week. So next Thursday. So at this point, we have had two View2 live. I believe we have worked out all the bugs about the technical problems so far. Okay. So starting next week, which is week 3, day 1, I'll start taking attendance. Okay, meaning that you actually participate in the class, just like you participate in the classroom. Okay, when I ask questions, I expect people to answer, and if we have any discussion, okay, we can do it in the chat room. Understand? So please subscribe to the channel. The video for today's lecture will be available sometime tomorrow, and then you can rewatch them if you need. This is a code that I'll put on ULearn because it does everything. It is not partial, it's complete. Then you can use it to try it on different images, okay, to see the results. The header itself in the BMP is fixed size. They don't change size. But the pixel will change size because for higher resolution image, the pixel number increases so as the number of bytes you need to use to save the file. Understand? So let's put a comment here. So at this point, I assume no questions on the assignments. Is that correct? Okay, that's good. Okay, yeah, you can send me email if you have questions. Okay. Again, the software is pretty straightforward to set up. And if you have problem recognizing the board in the computer, usually it's your user account problem. Okay, unless the board is dead. If the board is dead, of course, there's nothing you can do. But if the board is still alive, like we blinks, we can download program to it, and there shouldn't be a problem. Okay. All right. So let me close this, and I'm gonna post this on ULearn. This is a 24-bit. I'll post this on ULearn after class so you can review the notes. Again, our notes will be the highlights of the lecture, not the script of the lecture. Understand? Okay. If you're all set, what you can do is you can exit the chat room, and then I'm going to close the live in a few minutes.